Hello and welcome everybody to our next LinkedIn Live session. My name is Thomas Gunkel from Skyline Communications, Market Director Broadcast. And today I have Gerard from Arista with me. Welcome, Gerard.
Hi, Thomas. Thank you very much. I'm Gerard Phillips. I'm a systems engineer with Arista, and I focus on many things, but I include the move to IP for broadcasters, 2110, AES 67, all that sort of stuff.
Thank you. And today, what are we going to talk about? It's really about giving you a preview of what are we showing together at both the Skyline and Arista booth for upcoming NAB. And for those who don't know Skyline, the company yet, we are about 350 people, headquartered in Belgium, have a global presence in more than 20 countries in the meanwhile. And all we do is focusing on one single platform, which is called Data Miner, which is in essence a digital transformation platform, open to monitor, orchestrate, plan, deploy resources, but also we talk a lot about automation and orchestration. What about Arista, Gerard?
Yeah, so Arista is a switching and routing company. We have the majority of the cloud titans as our customers. We build very high quality, high performance switches and routers, which are used to power the internet, power pretty much every cloud you're operating on, and with a history in both multicast and high frequency trading, banking. Multicast and BTP are two of our very, very strong capabilities, and they match incredibly well with the kind of broadcast live production play out market. So we also are a strong player in the live production play out 2110, 2020-6 type media entertainment space.
Yeah, and since many, many years, we are working already together. And for those who don't know Data Miner and how things are going together, let me give you a very brief overview what the Data Miner stack looks like. At the bottom of that next slide, you see that's the customer's operation, on-prem, off-prem equipment, hardware, software, and that also includes certainly Arista switches and Arista solutions, what we call the data collection control plane. And out of that, we built a so-called digital twin, which is really a copy of all your operations that we run in the Data Miner memory that allows us to monitor and control everything which it gets exposed by any API, such as the Arista APIs we are using to interface with Arista switches or tools. And on top of that, upon that digital twin, we are adding automation mostly and what we call orchestration to run the customer's workflows, to automate as much as possible, and how to visualize things. That's what we call the data consumption. We have plenty of different ways to expose data to operators, to engineers. We will also see a couple of those today. Gerard, since many, many years, we are working together. I guess your company is out since when?
I think we've been public since 2008. Yeah. So we've been building switches and routers for a long time. We're primarily a software company. The power of software enables us to offer amazing APIs and loads and loads of telemetry, and that's essentially kind of what has brought our two businesses together. You guys consume the telemetry and the data from the switching infrastructure that we build, and you leverage that to deliver value to your customers. One of the things that's incredibly important to us is that visibility, because that allows you to be efficient. Those APIs allow you to both see what's happening in the network and to automate what's happening in the network. So that's kind of the basis of a lot of the partnership we have with you guys is we create great APIs that deliver the ability for you guys to add a ton of value to customers, having building on top of those.
Yeah, that's key indeed. It's all about what we say API first. And when you look back, like 10 years back, it started with a connector, as we call it, which was SNMP based. That's how it started. Then Arista evolved. There were new APIs that were coming up, features like S-Flow. For those who don't know what S-Flow is, maybe Gerard, you want to briefly explain?
Yeah, so S-Flow, so SNMP is a we'll talk a little bit more about SNMP and polling later, but S-Flow is a kind of a telemetry protocol. It allows the switch will take a series of samples from your packets. It will strip the data, leave you with a header, and then it'll packetize up those headers and send them somewhere. And so once you've taken away the payload, what you've got is just data, information about where it came from, where it's going to, the content types, for example.
Yeah.
And that allows something that consumes those S-Flow records to build a really quite a statistically accurate model of what is happening in your network.
And S-Flow is something we used, or we are using since many, many years now, especially in media, also to monitor multicast flows in the network, which was not possible with the SNMP based environment we were using back in 2014. But the more technology, the more APIs or interfaces you have added, the better visibility we also got on the Arista switches. And as you can see, it started with monitoring, control, more in-depth monitoring, things like S-Flow. You see something what we called IDP, stands for Infrastructure Discovery and Provisioning. This is a data miner toolset to manage the, for example, firmware device configurations on Arista switch fabrics. We also did then over the last couple of years SDN orchestration projects to manage 2110 environments, for example. Since a few years, more and more, and that's also key for today, we talk about streaming telemetry. We will today talk about Arista MCS, your network controller, and also something we are going to present the first time during NAB, what we call data miner media ops. And that constant evolvement, that's really key in the partnership, that this was not a one-off development and we use it for many, many years. There are new innovations coming from Arista like every year, and that's what we follow with data miner, with the way we have established that partnership since many, many years. Maybe on the monitoring side, for those who don't know, this is something we have built in the Arista lab, where we monitor key metrics, key parameters from a switch fabric. This is, for example, switch interfaces, the states, but also what we see here, digital optical monitoring for SFPs, where we get information in real time. We store that information. You see those trend graphs. Maybe, Gerard, a few words about your lab and how things are working on a daily basis, and how do we work together?
Yeah, so we really enjoy working with partners where they fully leverage the APIs, the flexibility of the software to really add value for their customers. And so one of the things we've built over the last few years is a lab, and in that lab it's externally accessible by our partners. And what we've got is a bunch of real switches with real flows, really connected together. And so our partners Skyline can kind of connect in. They can run their own software in the lab, or they can connect over VPN. And what they can do is they can really understand how our switches will operate in a real environment. And what it gives you is scale, because not every you guys don't want to build your own lab with tens of switches, but we've got one here, and so you guys can benefit from that.
And what you rightfully said, it's about testing, also developing our integrations against each other to really make sure and ensure we achieve the right quality of our connectors and integrations. And not only that, we can do that with a single switch. We also have an Arista switch in our own lab in Issegem in Belgium. But this lab is much more about also scalability and performance tests, because you have quite a decent number of switches and the full fabric that we can use to develop our solutions together, and to also showcase those, because that's really information, those dashboards, one of our ways how to visualize data, information we show and can expose in real time, also during trade shows and for customer tests. Whenever customers are interested, we can also give them access to those joint labs to do some real life integrations.
And I think the scale is really important, right? Because you can have a single switch in your lab, you can connect to it, you can use the eAPI or the open config as you wish, and you can get that telemetry. But once you scale that up to 10 or 20 switches, you may discover that there's something a bit slow, or it takes a while to do something. So to us, that is really one of the huge benefits. You guys can test at scale.
Yeah, absolutely. And We have learned those lessons plenty of times. And also when you look into customer labs, there we see the same challenges. Often they have 1 or 2 switches probably, but that doesn't scale to really do those performance and scalability tests. On that slide, what I also wanted to briefly talk about when we talk about monitoring, this is not only classic like threshold-based monitoring. We have something we call augmented operation. This is basically a set of AI algorithms that allows us to turn monitoring into something much more proactive. And one of the features we have, we do forecasting. As you see on that trend graph, that dotted line on the right, this is actually a forecast of a single metric optical RX power. By forecasting, when you are able to forecast things, you can probably forecast also potential issues and then react within a certain time frame to fix a potential problem that is not a problem yet. So classic monitoring, when you look into it, in the past you only ever got alarms when things were broken already. With AI capabilities and our algorithms, forecasting is one of the key things we are doing. And this is also, by the way, from a live system. There are other things in there on AI-assisted monitoring. Another example on SFP monitoring, which is called behavioral anomaly detection. This is really about identifying changes in behavior. And here you see on that screenshot a level shift, which was not qualified as an error yet. There's nothing popping up in red because the level shift was rather small. On the right-hand side, another screenshot from another real-life customer system where we again monitor SFPs, and you saw there another small level shift, and then there is a constant degradation. And on the very right-hand side, you see that small little red rectangle. This is already a forecasted problem in the future. We call it proactive cap detection. You see that dotted line again. This is where we are now. And with that, we were creating an error, which is not really an error yet, but in data mining, you get already an alarm as an operator saying, if you move on like that, if the behavior doesn't change, if that degrades further on, you will run into a serious issue into maybe a few hours. And that gives you sufficient time to react before things go wrong. And maybe, Gerard, you would also agree that classic threshold-based monitoring does not really apply anymore in a much more dynamic world where we are living to also in media, because there is nothing like the absolute threshold anymore. And even if you find a good threshold, that threshold is never the way as it, to say, if I set it too low, I might miss a few things. If I set it too high or vice versa, I have too many false alarms, and then operators just start ignoring those alarms.
Well, I think the key thing here is there's the rich data set that you have available to you allows you to train your models on this sort of stuff, right? So and that adds value in that it allows your models to be more accurate based on real events. Mm-hmm. And yeah, I mean, I would absolutely agree. The kind of thresholding techniques were not bad in the past, but these kind of adaptive models give you a much better view of the world.
So yeah, monitoring, looking 10 years back, which was maybe threshold based, very classic, has changed a lot. It's of key importance that people really think about monitoring in a different way to be much more proactive. Another small demo we have put together also in our lab, you see we can automatically extract the network topology, and we have made an overlay, not so much on alarming, but much more to visualize and analyze data. And this is a PTP example for, let's say, non-PTP expert, where we just color code the state, if it's master, slave, or passive. And with that color coding, it's easy to identify a bad PTP configuration. That's also something where we add really that level of media expertise onto it. A lot of toolings, we will see those. Maybe bring up the next slide already. When we talk about your cloud vision solutions, they are much more IT driven. What we do with Data Miner is adding that single pane of glass, but also giving it that specific media angle for media operators. But probably first, before we talk about telemetry data, a bit of an introduction on network visibility, Gerard.
Yeah, so Cloud Vision is our single pane of glass operations tool. It's available kind of on-prem or as a service. Its focus is on network operations, whether that's configuration or monitoring and telemetry. But I'm going to talk a little bit about the telemetry at the moment. So again, it's using this real-time streamed telemetry, which means it's not polled, it's not SNMP based. It's a live, connected, secure connection from each switch into CloudVision, delivering essentially events. I've learned a new MAC address, I've learned a new route, I've lost an interface, I have had to have some routes withdrawn, whatever it happens to be. So the state of the network is being continuously streamed from each switch into CloudVision. And in CloudVision, what we're doing is we're looking to extract value from that data by, we call them turbines, but essentially we're taking the data sets and we're processing them into events. So we're processing those data sets into things you should go and have a look at. And that could be, if an interface goes down, we'll try and suggest what the cause of that might be. Maybe it's a bad optic, maybe it's somebody took the other end down, maybe somebody did a shutdown at the other end of that link. So for example, we separate out expected link down and from unexpected link down. So what we're trying to do, and if you go and click on that event, then what we're looking to do is to give you the ability to see a little bit more data about what caused that. And of course, no presentation, as we've seen already, is going to be acceptable without the mention of AI. We of course have got AI built into CloudVision, where we're looking to determine trends and things that you should think about in the future. So the long and short of it is that with a really great set of data, we can deliver a really good network view. We're not attempting to give you the broadcast application view. That's not really our zone of expertise, and it's certainly not. We'd never be able to deliver that as well as these guys can, for example. Yeah. But our objective is a really, really quick time to find a network problem.
Mm-hmm. And for those users who ask how we did the integrations with Data Miner, we certainly follow your APIs. We have adapted our connectors or even developed new connectors using now OpenConfig telemetry data. The very same APIs you are using with CloudVision, right? There is no difference.
Very similar. So CloudVision itself has got a bunch of APIs, so you can ask it to do things. You can extract data. We use a very similar technology to stream the events from the switches to CloudVision. It is slightly different in the sense, of course, it's a private link, so we can do whatever we like. So as we change the models within the switches, we can track those models within CloudVision. Of course, when we come to OpenConfig, what you care about is those models are consistent. So you never have to, once we've delivered a model, you don't have to change how you interpret the data, because that would be a pain in the neck, right?
That's an important aspect, that we don't want to rewrite connectors or have broken connectors over time. So we need consistent APIs. And for those users, again, interested in, I just said we interface directly with the switches, are using OpenConfig telemetry data. But as you said, there is also an API available. And if for whatever reason, users prefer Data Miner interfacing with CloudVision and getting information from there, that's also possible. So either straight from the switches or through your CloudVision subsystem, as I would call it.
Yeah, I mean, our objective is to offer as many APIs as makes sense, that deliver different things, and then different customers or different partners integrate in different ways. So whether that's our eAPI, which is essentially our CLI wrapped in a RESTful JSON type interface, or OpenConfig, which is an open standard method of streaming, control, and telemetry, we don't really mind. I mean, people consume the data as they wish. Here we've got a very quick. It's a prompt to talk a little bit about sampling, whether sampling or stream data is a good idea. The bottom line is, if you're using something like SNMP, then on a small system, you can maybe poll it every 10 seconds, and maybe you've got some traps. But on a big system of 10 or hundreds of switches, that kind of polling time turns into minutes, tens of minutes. And so you're potentially in a zone where you don't have visibility. The granularity of your visibility is every 10 minutes. And that gets you to a situation where something could be broken for 10 minutes without you knowing. So that's kind of where this view of streaming data comes from. You might think streaming creates more bandwidth. But actually, if you're only streaming changes, actually turns out you're streaming a lot less data. And from that data, you can create a huge amount of useful stuff. You see in the middle, we've got some kind of flow analysis from SFlow. At the top, we've got kind of analysis. We've got kind of donut graphs showing, I'm not sure what that was showing, but it's showing us interfaces properly. And one of in the bottom, what we see is you can see the timeline. So one of the big things that CloudVision can do is store a load of data for a reasonable period of time. So when somebody tells you that the problem happened yesterday at 3:30, you don't have to wait till it happens again. You can go back to 3:30 and go and have a look at that data.
Yeah. Okay. There's also a bit of a media aspect, especially when it comes to PTP. You have added to CloudVision, I learned.
Yeah, so new feature. It's coming out pretty much now. It'll be available in both on-prem and CloudVision as a service. And what we've done is we're now consuming our own PTP status information, and we can now present that overloaded onto our topology view. So we have a topology view. It talks about what VLANs are stretched, what bandwidths are being used, what links are happy, what links are not happy. You can see all sorts of other overlays, but one of them now is PTP. So we're showing here the topology of the PTP. You can see we have a dotted link. That means we know that's where our master-slave relationship is, but it's not a direct link. Maybe that's the GM, but we don't have an LLDP neighborship, or maybe that's across a transparent clock or a non-PTP aware clock. But the rest of the links, you can see the kind of the green and the arrows are showing us where these switches are being driven from. You can see this one over here that's purple. That's locked to something else. So that's not part of our current. It's not part of our designed network. So we should look into that. To go with that, we've got a few new events that turn up in our events pages and can turn into notifications. So if we don't have a consistent GM ID everywhere, we'll tell you about it. If we don't have a consistent set of domains configured, we can tell you about it. So brand new stuff, all useful stuff.
All right, thanks very much. And for those not being so familiar with polling and what we call on-change subscription, where we use OpenConfig, we have built a very super simple demo. And you just saw we brought an interface down on the lower part, the OpenConfig on-change subscription. It immediately was showing up in real time. Whereas with a 30-second polling interval, you see there is always a delay. And as you said before, if you have a higher polling interval than only like a couple of seconds or 30 seconds, like in that example, there is even a high risk that you miss some events completely. So I could bring down an interface and bring it up again between those 30 seconds polling interval, and we would not even realize and miss that event completely. Whereas with OpenConfig on-change subscription, we have those real-time notifications, less traffic, as you already said, and the guarantee that we don't miss any of those small, let's say, hiccups or mini events. Another part I want to talk about is, next to monitoring today, SDN control and orchestration. There are plenty of ways how to do SDN. That could be something simple like IGMP, where data miner talks to the edge devices, sets the multicast routes, and an Arista switch fabric, we call it then a self-converging network, takes care of the rest via IGMP, and that's how we can make connections. We also did, I mentioned it before, full SDN type of controls on an Arista switch fabric, more in the contribution space, more for scheduled events for 2022-6 or 2110 streams, where data miner calculates and sets a path on each Arista switch, maybe on a WAN network, sets then the multicast IPs at the destination, reserves bandwidth ahead of time, which is one of the use cases. But when we look into live productions, for example, where it's all about being deterministic, fast, and real-time, you have something called Arista MCS. And maybe before we talk about how we integrate with MCS, let's have a quick look what MCS is at all.
Yeah, so MCS is a media control service. Primarily, it's multicast, but what we're doing is we're providing bandwidth-aware pathing through the network, and it's also incredibly high performance. So very, very fast switching, faster than the eAPI, faster than OpenConfig, and with an awful lot of, again, it's in our genes, a lot of telemetry being pushed back to broadcast control in this case. And so what we're aiming to do here is just to safely maximize your network performance in terms of speed and in terms of throughput. And so MCS sits as a very, very thin layer between the broadcast controller and the switch networks. And we can support red and blue type architectures, or purple leaves for audio endpoints, or purple spines if you want to build a full purple network. So it's maximizing the benefit of your investment, really, using some clever software in the middle between the broadcast controller and the network.
Yeah. And I guess you have a few new features available in MCS. Maybe briefly introduce that. And I just realized I need to change something on my window here because the sun is coming across the corner. That fixes the problem, I guess. Okay.
Sure. So we have a maintenance mode, which allows you to safely put a switch into maintenance, which would allow you to upgrade it or apply a patch that requires a reboot, for example. Not that many of our patches do that, but this is an API that the broadcast controller can use to say, please start not using this switch anymore. And flows will either gracefully degrade off it as they're not used, or the broadcast controller can see our notifications and can then choose to reroute stuff. And that happens kind of transparently in the background if that's the way the broadcast controller would like to operate. So an operations improvement to MCS.
That's a nice solution also for us, because data miner, we talk a lot about managing plant maintenance slots, meaning taking equipment, devices, capacity out of the available pool of resources or capacity. And that's exactly what we can do then via that API, to say we remove or reduce the capacity of the available network for a certain point in time. We would also probably remove then some of the edge devices, and altogether people can manage then their plant maintenance slots. And at the same time, we guarantee that every single stream can still be managed in that limited network with limited capacity for a certain while. And once things have been fixed and the plant maintenance slot is over, we bring back all the resources, all the capacity back to the operators, that they can book the full capacity again. And one more we want to talk about is on, let's say, a bit of bigger systems with different zones, but you are the expert.
Yeah, so what we're seeing is broadcasters are connecting zones together. They're connecting studios together, connecting different maybe play out and production, or maybe they're connecting to a partner. And so what we're looking to add is we're adding features to MCS which allow it to manage those connections in a bandwidth aware mode, which leads to smaller failure domains, because you don't have a single huge MCS instance. You've got multiple instances of MCS operating locally, providing the feature set locally, but allowing you to have the benefit of the bandwidth awareness globally.
And for those who are wondering how things are working together, we put together a small demo. On the left-hand side, you see a data miner we call low-code application, control surface, a very simple XY routing panel, senders, receivers, sources, destinations, connect button in between. And in combination with Arista MCS, what are we doing under the hood? You see that on the right part. Those are screenshots taken from our data miner engineering user interface called Data Miner Cube. On top, you see the MCS API call. What is the result? There are 3 entries in the MCS connector. You see we have made a connection by clicking on the connect button as an operator across a leaf, a spine, and leaf switch from a certain source IP with a certain destination multicast IP, our 232.101.1.1, and we have reserved 3 gig of bandwidth. And MCS takes care of finding and setting the path. And as a second action, based on the fact that somebody hit the connect button, we had a NMOS ISO5 capable end device, an ISO5 receiver. It's that simple as sending an STB patch command to make the connection happen. So that's how things happen under the hood. Data miner user interfaces on top, and then underneath we talk both to MCS via its API and the endpoints, the receivers, to make sure that connection happens for the operators as simple as they were used to work in an SDI world. I want to wrap it up with talking a little bit about flow monitoring, flow tracking. What you see here is another application we have called Flow Monitoring app, split in two things. You see the as engineered path. This is the path we have configured from the camera 1 to our monitor 1 with Arista MCS in between, like a bit of a black box, but it goes from source to destination. And what are we doing then? We do a cross-check, and this is what we call the as-is path. So now we use our OpenConfig implementation, talk straight to each and every switch, to the leaf switch, the spine, and the other leaf switch, and cross-check if that multicast, that static multicast that has been configured by MCS, made it to each and every switch. Why are we doing that? Things in reality can go wrong every now and then. And maybe also from your experience, Gerard, you know much better what goes wrong every now and then and why, like cross-checking things make sense. This is really, in my eyes, a bit of a troubleshooting tool, what we call flow monitoring here.
Yeah, I mean, these are complex systems, right? There's a lot of moving parts. And so having some sort of an audit trail, the ability to debug, the ability to double check that what the operator requested has actually physically happened is super, super important. Yes, absolutely.
Yeah, I always say in the past we could run after the green BNC cable. That's not possible anymore. So operators, engineers, they need a different set of tools to be able to troubleshoot their network in a much more complex environment than SDI ever was. And if you wonder what those apps are, you have seen that control surface app, you have seen that flow monitoring app. There are other apps also to do planning cross points, planning complete jobs, events, everything you do in media operations upfront. That's something we are going to present during NAB. We call this data miner dot media ops, media operations, which is in essence a set of predefined low-code applications people can download from our catalog, use it as an off-the-shelf app, and if they want, reconfigure and fine-tune, because it's an open platform, to really manage a complete workflow from inventory, onboarding, planning, reserving, deployment, connect and control. And what is key for that, you see it already, that needs dedicated integrations. Technically, we are fine-tuning all connectors, and we have done that already with Arista MCS connectors and with our Arista OpenConfig connector to provide that off-the-shelf experience, which allows us to go into production much faster. And that's something we are working together, as we have Arista as one of our key tech partners. Your connectors were obviously one of the first ones we have implemented and added to MediaOps to make things compatible. And everything you are going to see at NAB, and that will be important, those demos, those conversations you can have at both the Arista booth, at our booth. As Gerard already said, we are sharing real-time demos from your lab, from our lab. We have all access to that, and we would be very happy to welcome you either at the Arista booth in Central Hall, or we are in the West Hall with Skyline Communications. And Gerard, before we wrap it up here, there's one more very important event on April 14th.
Yeah, if you're NAB and you fancy coming along to the Media and Entertainment Advisory Board, which Arista holds every year, we have a couple of customers who are going to talk about long-term customers who have built 2110 systems. They're going to come and talk to us about the lessons learned. So if you'd love to come along to that, we would be very pleased to welcome you to that. Please reach out to an Arista, to your account team, or ping me on LinkedIn, and we'll get you an invite. It'd be great to see you.
Thank you. And I guess with that, we can say thanks very much. See you all at NAB, and hope to see you in Vegas. Thank you.
Yep. Thank you very much, Thomas.
Thanks,
I really enjoyed that. See you in Vegas.
It was a pleasure, and see you soon.